Today I'll be talking about indeed like how societal biases are reflected within AI algorithms. But before I begin, I first want to give a little bit of an introduction about myself and why I specifically chose this topic. So first of all, I'm a data scientist at Bol.com, and I've been involved with the international work group over the past few years, mostly because I think it's very important that Bol.com is perceived as a very welcoming and open employer, irrespective of whether you speak the Dutch language or not. And last year we organized the Intercultural Awareness Week, which I think was a nice success. And this year we have a full month actually devoted to diversity and inclusion, which actually overlaps, of course, with the Spaces Summit. So when I saw that there was an overlap between the two, I thought it would be really cool to actually have a diversity and inclusion themed talk. It would also be a little bit tech related. So that's why I kind of landed on the topic of societal biases and how they're reflected in AI algorithms. Now, when we talk about diversity and inclusion, one of the things that I think is one of the most opposing forces to or against diversity and inclusion is societal bias. And when you look at sort of the definition of bias, it is basically that it's an implicit or explicit disproportionate weight in favor or against a group of people, depending on certain characteristics of that group of people. Now, when you kind of simplify this, it kind of means, you have a preference for or against a certain group of people. And when you kind of make this like an individual thing, you can have individual preferences, and that's okay. Bias in and of itself on an individual level does not have to be a bad thing. However, when you kind of scale this up, so if you have a certain bias or a certain preference for a certain group of people, and it's actually scaled up to a way that you go to a societal level, like a large group of people, then other people are going to be disadvantaged. And of course, that is an actual problem. Now, when we talk about societal biases, the typical bias that you know and you should know about is like gender bias, racial bias, bias in terms of sexual orientation, religious bias, and maybe in a little bit of a less prominent, but also, for instance, bias based on education level or income level. And those last two are also a little bit sort of correlated with the other two as well. And these biases, they're really ingrained within ourselves and also in our society. And that's because this behavior has been in ourselves, in our system, in our history, in our cultural values for very, very long. And because it's so ingrained in us and in our society, we often don't really notice that we have these biases on a larger societal level. But of course, it is a problem, and we're becoming more and more aware of this. Just to show that bias is still actually quite a big problem even in the 21st century, these kind of societal biases. I have a few headlines here for a few news reports that I found on the internet from very, very recently. The first one is about gender bias. So in the UN report on gender bias, they actually found some quite startling discoveries. They found that 40 to 50% of people, including men and both women, think it's actually a man is more fit to be a politician or a business executive. Or I think even more shocking, 30% of people think it's okay for a husband to hit their wife, which I think is pretty appalling, but it just goes to show that this is still a pretty big thing. 30% is quite a large group. Going to more sort of the sexual orientation bias, here you see that homophobic crimes rise by more than a third in France, meaning that the bias against certain non-heterosexual orientations, it's there, and it's actually becoming more and more explicit, and also the way it's exposed is becoming more explicit and more violent. And finally, a very sad message about a black man recently being shot to death while jogging in the US, with there being a very clear indication that there's a racial bias for the motivation of the shooting to begin with, and also that there seems to be a racial bias in sort of the justice investigation afterwards. So I think it makes it very clear that bias in our society, it's still very much alive, and it's still very much impacting a lot of people. Now, what does this have to do with AI? AI or algorithms in general, or machine learning, I'm going to use these things interminglingly, so I will use them in different times, different words. AI or algorithms are becoming more and more present in our everyday life. We have them in our smartphone, we use them when online shopping, at Bol.com, for instance, or anywhere else. When we browse the internet, there's a lot of algorithms making decisions for us. We have smart homes, which kind of dictate how our homes work. We have voice recognition, all of these stuff, they're algorithms. They're algorithm-based, and it's becoming more and more prevalent. Also, if you go a little bit further away from everyday life, like for instance, healthcare or law or finance, all of these things, all these areas are becoming more and more algorithm-driven, and there's algorithms making decisions for us and about us. So these decisions can be quite impactful as well. So we have to make sure that these decisions are fair and objective and not filled with bias. But are they actually fair or objective? So here I have another few headlines from news reports from the internet, and also a few academic papers, which basically goes to show that AI or algorithms actually do have quite a lot of societal biases in them. Going from recruiting to actual language to, for instance, how the police works or law, there's actually quite a lot of things which includes algorithms that actually are biased. Now, isn't that kind of weird? Because artificial intelligence is supposed to be objective. It's supposed to be better than us. It shouldn't be anchored down by opinions or preconceived notions. It should be objective and be able to make objective decisions. So how come it is still biased? Now, to be able to explain this a bit, I'm going to go to sort of the basics of machine learning in AI, just to be able to sort of give you a basis of what it means. And I'm going to go into a few examples of how basically these basics can explain these biases occurring in computer algorithms. So machine learning, the definition is basically a set of algorithms that can discover patterns in data and can act on these patterns without actually being explicitly programmed to do so. This last part, being explicitly programmed to do so, means basically that there is no preset rules, there's no if-then statements that kind of dictate these rules. The algorithm decides itself what it needs to do based on the data it sees. Now, to be able to sort of construct a machine learning problem, you need a few things. First of all, you need a goal. What do you want to achieve? Typically, this is a prediction of some sort. So for instance, say you want to predict the gender of a person. That is the thing that you want to achieve. So that's your goal. With sort of technology becoming more and more advanced, you can also see this sort of going more towards data generation and data augmentation. Although you could still sort of reason that this is sort of like a variety of prediction. For instance, when you look at deep fakes, like the videos where they superimpose someone's face over another one's face, which is basically a prediction of what the face should look like in the situation within the video. So then the question becomes, what do you want to predict? And this question basically informs you about the other two things, the data and the algorithm that you want to use. So first of all, the data is very important for a machine learning problem. Can basically be chopped up into different things. You have your features, which is basically your input data to the algorithm, which basically is data that describes the thing that you want to predict. So it has some kind of relationship to what you want to predict. For instance, going back to the gender, this prediction case, you might think, okay, if we wanted to predict someone's gender, we can include things like height or weight, which would be good features. But you could also, for instance, include eye color or hair color. Not very good features, but you can still use them as input. The other thing that you need in terms of data is often some kind of label or target. You need to make the algorithm see a correlation between the input data and the thing it needs to predict. So you need an optional ground truth to be able to make that connection. Finally, the algorithm. There's dozens and dozens of algorithms out there. I'm not going to go through all of them. I'm just going to keep it very simple. Typically, you have two types, regression versus classification. Regression is when you try to predict a continuous variable, for instance, how much a house will cost. And classification is somewhere where you can divide the thing that you want to predict up into discrete classes. So if we say gender is binary, which it's not, but say it is, then the prediction of gender would be a classification problem. Then, of course, you have different levels of complexity. For instance, linear regression versus deep neural networks, with linear regression being a very simple kind of model algorithm, and deep neural networks being very, very complex, basically when you need to do something with very complex data or something that's hard to predict. Then finally, we have some kind of feedback mechanism. The model needs to know, needs to be able to know whether it's doing the right thing. So it needs to be able to learn. So you need some kind of feedback mechanism which basically tells the model how well it's doing while it's learning. Now, this is a very nice basis, but can you still explain bias by this? I don't think so. So I'm going to go a little bit deeper. So how can machine learning models then end up biased given this basis? I'm going to try and sort of explain this by comparing how humans learn versus how the algorithm learns and what the difference is there. And the key word here is context. So to begin with, as a human, when you learn, we have all this experience that we can draw from. We have all this context that we can draw from, which is not really related to our problem, but which we can use to sort of learn quicker. Whereas algorithms are sort of confined to the context in which they are set. So the machine learning problem that you create, that's the only thing the algorithm will know. It will not know anything else. So it will have only this little set of basically this context to go and do its work. Also, humans have common sense. We're able to connect all of these contexts together to be able to sort of make a best decision on how these things interact with each other, and also to learn quicker. We know, for instance, that a Chihuahua is a dog, even though like also a Golden Retriever is a dog, even though they're very different. So we are able to connect these things together, and we kind of have an implicit idea of what value is, for instance, the value of information, and we can make connections between that. Algorithms, on the other hand, really have a hard time extrapolating because they cannot go beyond this context to be set for them. So if an algorithm is fed new data, or data that it's never seen before, it will have a hard time actually doing anything with it. Finally, as humans, our brains are really good at learning, but they're not really good at computing. If you give me 10 gigabytes of data and ask me to find a relationship in there, I will not be able to do it because it's just too much for me to handle. Whereas, of course, an algorithm and computers, they're designed or optimized for this. So they're much better they can much better use all this data to go very deep into it and actually find things that we, as humans, would never be able to see, relationships that we will not be able to find. Also, an algorithm is not really confined by the expectations that we have. As I said, we have all this context, and we kind of make implicit relationships between these contexts, and also sort of have an implicit value of what data is important, what data is not. An algorithm doesn't have this. It doesn't have any a priori expectation. It just takes everything you give it as face value. Now, how does this actually then end up in bias? So I'm now going to give you a few examples, because data is the most important part. So if you replace context with data, and the data is actually the thing that we can sort of control the most in the machine learning problem, then you can see how the biases start to develop. First example I'm going to give is about Amazon. First of all, I think it's our main competitor, so it's kind of cool to see them kind of feel. On the other hand, it's a really large company. So Amazon is a large company with a lot of funds, with a lot of resources, and they have a lot of experience with AI. Yet they are not able to actually work this problem sometimes. Like, this is actually a problem for them as well. So it actually just goes to show how big this problem really is and how hard it is to solve. Back to the example. Amazon actually wanted to create a recruiting tool powered by AI that would actually help them with the recruiting process. So if they have hundreds of resumes, this recruiting tool, this AI would basically go through all the resumes. It would actually check which of the resumes have the right skill sets, which have the right words, and it would then sort of make a filtering saying, okay, this one resume is good, all the other ones you can toss away because they're not really valuable. And then it would actually speed up the recruiting process by a lot, having much less manpower to actually do the recruiting. It's really nice, but as I said, it didn't work. So what happened? The thing is, Amazon had an already existing bias, a gender bias. So normally, ideally, you would want to have 50-50, but in Amazon, the distribution was not 50-50. There's way more men working at Amazon than women. And of course, the data that they use for training the model had this bias in it as well. They used their own recruitment history to be able to train this model, meaning that the good resumes were basically mostly men, or predominantly men, whereas the bad resumes for the model maybe had a disproportionate large fraction of women. And the model kind of picked up on this in an unexpected way because it doesn't have any prior knowledge of what is bad and what is good. So when it would see a resume from a female, and it would see the words women's college and women's swim club, it would see, okay, but in the past, the resumes which have these terms in them, they were rejected. So it would learn that the words women's would actually be bad words. And it would actually sort of reject the resume based on the fact of the word women being in there. And of course, the word women has nothing to do whatsoever with skill or skill sets. It doesn't say anything about someone's qualifications, sorry. So obviously the model did the wrong thing, even though I thought it did the right thing. And that's because, there is this inherent bias already in the data. And the worst thing is, in the end, Amazon kind of scrapped this whole project before it went live, but if no one had noticed this, it would actually start enforcing the bias. It would actually start, rejecting women, hiring more men, which basically would make, the bias even stronger than it already was, which would again make the algorithm more biased towards men, and we could basically have a positive feedback loop. So the algorithm would actually make things worse. The next topic I want to discuss is facial recognition, mostly because I think this is it's a very sort of contemporary topic, becoming more and more important to our sort of everyday lives. We unlock our phone based on facial recognition. So it's a technology which is very useful, but it's also sort of riddled with potential bias. Because facial recognition is quite a hard problem. It's a lot of data that the algorithm needs to see to be able to do it well. So you need a lot of data to put in there. However, the training data often is public data, so public images of people, meaning that often the training data is not very diverse. It's rather unbalanced, with having a lot of images of white men, whereas having very few images of women or people of color. So those are more underrepresented within the data set, meaning that the model has less data to look at for those specific types of people, and therefore is less advanced or less accurate for those people. And of course, it can lead to very embarrassing situations. So this is from a study a few years ago, where they used facial recognition algorithms to basically do gender prediction. And what you see here, and they used 3 different algorithms, also from Microsoft and IBM. And here you see that the error rate, so basically the percentage of people predicted incorrectly, was almost 0 for a light-skinned male. So light-skinned male, the algorithm really did what it needed to do. But as soon as you deviate from that, so even for a light-skinned female, you already see the error rate go up. So the training data, there was not enough light-skinned females in there to actually make the algorithm as good as with light-skinned males. And then for the darker skin, it actually gets worse. So the dark-skinned female is the group which is predicted worse. And this is just a gender classification problem, which is relatively simple. So there you can already see algorithms going wrong. But of course, these algorithms are also used for other things. For instance, facial recognition, where you actually match faces. For instance, unlocking your smartphone, or maybe doing checks against mugshots to be able to sort of trace or identify potential suspects of crimes. And there's a lot of news reports already where you can see that these things go wrong. For instance, the top right here one, it says that when you try to match faces, like using, I think they used about 190 different algorithms, it shows that African American and Asian faces are 10 to 100 times more likely to be falsely identified than Caucasian faces, meaning that if you have a smartphone and you have a darker skin, then someone else with the darker skin is more likely to be able to unlock it, even though it shouldn't be. Also, of course, very embarrassing is Google actually having an algorithm which mistakenly called black people gorillas, which is super embarrassing. But again, Google is a large company and they make these mistakes, showing again that this is a really, really hard problem. Another one with an Amazon-based recognition algorithm actually was tested on members of Congress, US Congress, to see whether they could match them with mugshots. And some of them did. And again, disproportionately many of darker skin. And the final one that I have on here is kind of also a bit scary, basically saying that self-driving cars are less able to identify darker-skinned people as pedestrians. So that could actually lead to, well, accidents further down the road, quite literally. Another one example that I wanted to go into is this one, because it's slightly different. Of course, sort of underrepresented classes is a thing in this one as well, but it's also something else. So this is about a viral face app, which was launched a few years ago, which had a few filters, which could, for instance, could turn you in the opposite gender, or could make you older, or could make you hot. So they had this filter, which was called the hot filter, which would make you more beautiful. But rather than make you more beautiful, it managed to actually mostly make people more white. So here you see a few examples of 2 people who actually saw their skin whiten when actually applying this filter. Now, what went wrong here is not just the fact that it's an underrepresentation of classes, it's because they wanted to try and predict beauty. Beauty is, of course, a very, very subjective notion. It's not an objective thing that you can predict. So actually trying to predict what is beauty and trying to have actually an algorithm trying to sort of transform people into a picture of beauty is already fundamentally wrong. It's never going to work, and people are always going to be upset by this, whichever definition of beauty that you choose. The fact that they actually chose mostly white-skinned people to represent beauty is, of course, another layer on top of that, which makes it even more problematic. And this basically managed to sort of make the algorithm see that white skin equals beauty, which of course is a very troubling notion. So just to recap a little bit, what can go wrong with algorithms? First of all, training data can have an existing bias, which can propagate into the algorithm. The second one is training data can have unbalanced classes, meaning that the algorithm doesn't see enough data to actually do its job properly for all of the classes that it should. If an algorithm is biased, they can actually start enforcing the bias. And there's quite a few examples out there of algorithms enforcing the bias and actually making a societal bias worse than it actually already is, which of course is very problematic. Finally, the last one I said is the goal of the prediction is not free of bias. So if your goal of your prediction is not an objective thing, or actually has an implicit bias in there, of course your algorithm will also end up biased. And finally, I didn't really go into this in detail, but data can be manipulated, especially data that's, for instance, online, and models and algorithms that are trained online and trained with online data and are able to interact with people. You can manipulate this data and make sure the algorithm goes crazy. I think Tay, the Twitter bot from a few years ago, some people of you might know this one, actually is a great example of this, because basically within hours, because of sort of a targeted attack, it would start spouting lots of inflammatory remarks, tweets, basically showing it was corrupted by people manipulating data. Now, this is of course all, well, not very nice, but we need to go somewhere from here. So how can we solve this? The first thing, of course, is solving societal bias, because that's in the end that's the source of this. But that's something that we cannot really easily do. So then the question becomes, how can we sort of solve the problem for algorithms in itself? Well, the first option is basically more scrutiny. So if you develop an algorithm that has something to do that could involve a societal bias, you need to be very, very careful. And you need to make sure that you test against these biases. You need to make sure that you design your problem in such a way that you take away the potential biases that could be in there. But that's, of course, hard work, and you never know whether you're missing a bias or not. So you need to monitor, you need to be able to sort of determine which biases might be in there, and still something might slip past. So it would be a lot of work. The other thing is law, so regulation or legislation could actually help with this. Obviously, there's anti-discrimination laws out there, but they're not really applied to algorithms just yet, because these algorithms have been around only relatively recently. So these laws are not really applied to them yet. But of course, this could be something that could be enforced in the future. So actually have legislation which says that an algorithm cannot be discriminatory in any way, shape, or form, which would actually force the creators of these algorithms to do something about the bias that might be in there. Also, transparency could be very important. Having, for instance, external audits based on algorithms to be able to check the data, check the algorithms, see what's going on, could be a way of filtering out biases before they become a problem. But a lot of these algorithms, of course, are from companies like Google, companies like Amazon, companies like IBM, which, of course, have an interest in keeping these algorithms a secret. So this transparency is hard to achieve because it's kind of like proprietary data to begin with. Then, of course, improving diversity is always a good thing, but also for this specific problem, because having a more diverse team will also help you sort of be able to see from different experiences and different expectations. You can design the machine learning problem in a better way to make sure that you filter out biases before you begin. Right now, I think a lot of machine learning teams, data science teams, are very white male dominated. Obviously, I'm a white male as well. So that's of course an issue, and if we want to sort of improve that, we could maybe see whether we can actually increase this diversity more. Finally, machine learning or algorithms can actually help algorithms to be less biased. There's a lot of work being done in this field, mainly because more and more people start to understand that this is an actual problem that needs to be solved somewhere in the future. So there more and more algorithms are being developed to actually help machine learning algorithms to sort of de-bias themselves by either identifying potential sources of bias within the data, or for instance, automatically oversampling data that's underrepresented within the training data. Just to summarize, so I'm at the end of my talk. Hopefully I have been able to show you that machine learning is a product made by humans, and therefore is susceptible to all the inherent societal biases that we also have. And that we need to be very, very careful with these, because they are becoming a more fundamental part of our everyday life, with basically every passing day. And we need to be very, very careful, basically when sort of crafting these algorithms and crafting these problems, to make sure that we make sure that they're fair and make sure that they're objective and make sure that we don't actually start exacerbating the societal biases that are already in there, because then we're just making the problem worse. And we don't want to make the problem worse in this day and age. We just want to make it better. So that, I think, is something that we need to be very careful for, and definitely not trust the model to do the right thing on its own, because the model is only limited to like a very, very small sort of scope. It does the best it can within the context it has, and the model doesn't know it's doing anything wrong. So that's sort of a responsibility that we need to take as data scientists and machine learning researchers and engineers out there to be able to do this properly. And with that, I would like to thank you for listening. I hope it was interesting.
Yeah, thanks, Ernst. That was a really interesting talk, actually, touching really important subjects. There were quite a few questions in the Q&A chat. Let me start. Nicolas says, so the conclusion is that AI is looking at us like parents and just behaving as we teach him to behave.
In a sense, with the additional complexity that the AI can only look at like this very small thing and doesn't have any prior understanding of what it's supposed to do. It just does the task that we want it to do to the best of its ability, but to the best of its ability can still sort of include bias, because we just kind of introduce it with bias.
True. Rob asks, do you have any examples of bias in Bullet.com?
That's a good question. I think Bullet.com, I think less so. I think as sort of a data science team within, or data science efforts within Bullet.com, I think we're kind of bounded by the people that visit our website. So we are not doing anything for like larger scale people. So for instance, like the things that I showed you, for instance, about recruiting, we never go beyond our customer base. Doesn't mean that there is no bias within our customer base, although I don't think I've ever actually seen any examples of bias just yet.
All right, thanks. Niels is saying, how can you find the classes and thus determine they are unbalanced if you don't know yet what classes the algorithm is going to find?
So that's depends a little bit on the type of algorithm, I guess. So for instance, with the facial recognition problem, the number of classes is not sort of predetermined. It's sort of about how we assign the classes. So like the darker skin male, darker skin female, lighter skin male, that's something that has been applied afterwards. And this, of course, something where you yourself needs to make some kind of judgment. And in that sense, so there's a responsibility there if you do this kind of work where you actually sort of deal with, for instance, facial recognition. You have to make sure that you're going to be right, or at least right enough for all these different classes, and then it becomes your own responsibility to be able to sort of make these classes. And it can be that you're still missing some, which is of course the problematic part, because you don't know what you don't know. I think there are currently developments, which I also mentioned a little bit within machine learning themselves, where they actually try to sort of identify these classes in advance. So within the training data, sort of find the feature space where there is less of. I think that's sort of still very much early work.
Okay, great answer. We have time for one more question. Let's see, wouldn't transparency in training data be more important than transparency in algorithms?
I think so, yes, definitely. Being able to see the data and what it's based on can be essential in identifying bias. But even there, companies who train these algorithms, they often have their own proprietary data sets, which they're not willing to share, which of course becomes a problem because we cannot really look at what they're doing, meaning that we don't really know whether there is bias in there. And this is of course also the reason why these things only sort of come out after the fact, as in someone needs to be affected by it before we actually recognize that there is a bias, which is kind of really late in the process, making the problem even bigger, because now we are not able to actually sort of do this in advance because we don't see what data goes in. We're not able to proactively check the data and the algorithms to be able to sort of prevent bias.
Okay, thanks. Yeah, this is a really interesting subject. So let's continue the discussion actually on the Google chat room that we have. You can ask more questions there. Thanks a lot, Ernst, for your talk. That was great.
Thanks for listening, people.